So we have question 13b from the past paper I've been going through, and we did part A, which involved working out the volume of a cornet outside a cafe, and now we need to work out the volume of the smaller cornets they sell in the cafe. So it states that the actual cornets that the cafe sells are similar to the plastic one. For the actual cornets, the cone and the hemisphere each have radius 2 cm. How many times greater is the volume of the plastic cornet than an actual cornet? So for me, what made sense was taking the volume of the cornet we found in part A, and then if we divide it by the volume of the smaller cornet, then we will work out how many times bigger it is in volume. So we just need to work out the volume of the smaller cornet first, as we know the volume of the bigger cornet from part A. And we are missing one crucial thing for this, and that is the perpendicular height of the smaller cornet. Now, because the larger cornet is 24 centimeters in radius, and we know the smaller one is 2 centimeters in radius, I'm going to assume that it is proportional, as it states they are similar. So when you take 24 to 2 centimeters, it is 1/12 of the size. We're dividing it by 12. So if we take the perpendicular height of the larger cone, which is 117 centimeters, and divide it by 12, it will be the proportional height. So hopefully that bit made sense. If it didn't, just leave a comment down below. So we know the height of the smaller cone is going to be 117 over 12 centimeters. So we got all the measurements we need now. So let's work out the volume of the smaller cornet, and we'll do a similar method to before. So we'll work out the volume of the hemisphere and then the volume of the cone. So the volume of the hemisphere of the smaller cone will be 2 over 3 times pi r cubed. Subbing in our values, that will just be 2 over 3 times pi times 2 centimeters cubed. That's going to be equal to 16 over 3 pi centimeters cubed. And as I said in my last video, I like to keep pi as a whole and give my answers in that form. So the volume of the cone will be 1 over 3 times pi times r squared times h, because as we saw in part A, we have the volume formulas here. So subbing in the values for the volume of the cone, it'd be 1 over 3 times pi times 2 centimeters squared times 117 centimeters over 12, and that's going to give us 13 pi centimeters cubed. So now we've got the volume of the hemisphere and the volume of the cone for the smaller cornet. We'll add them together to get the volume of the smaller cornet. So that's going to be 55 over 3 pi centimeters cubed. So as I stated before briefly, we have the new volume and we have the older volume. So if we take the volume of the larger cone and then we divide it by the volume of the smaller cone, we'll work out how many times bigger the larger cone is than the smaller one. So the volume of the smaller cornet is 55 over 3 pi centimeters cubed, and the volume of the older cornet was 31,680 pi centimeters cubed, so quite a lot bigger. And if we divide the volume of the older, larger cornet by the new cornet, the smaller one, we're going to get how many times bigger it is. So times greater is going to be 31,680 pi centimeters cubed divided by 55 over 3 pi centimeters cubed. So it turns out that the plastic cone outside is actually 1,728 times bigger than the cones they serve in the cafe, and that is in terms of volume. So hopefully that made sense. Hopefully it was clear. If it didn't, leave any questions down below. Best luck with your maths, and thanks for watching.